the angular momentum of an electron in Bohr's orbit of hydrogen atom is this, that is 4.2178 into 10 to the power minus 34 kg meter square per second square. So this is what? This is the angular momentum. What you need to do is calculate the wavelength of the spectral line emitted when electron falls from this level to the next lower level. Now what we know here is, first of all, while solving the numerical, we just tried to find out what we know. What we know is, we know just the angular momentum. We don't know anything else. Okay. So we know the angular momentum. It is answer 3. Now angular momentum. How much it is given? It is 4.2178 into 10 to the power minus 34 kg meter square per second, right? Now what is asked? You are asked to find out the wavelength of wave emitted when this electron moves from the given energy level to the next lower one, right? Now first of all, we don't know where the electron is residing. Do you have an idea? No. So first of all, what you need is find n. Do we know n? Where it is residing? No. Find out n. Now what formula we can apply here? We have this Bohr's quantization formula. What this Bohr suggested, that the angular momentum of an electron in any orbit, or it is the angular momentum, Bohr suggested that electron can move in those orbits whose angular momentum is integral multiple of h upon 2 pi. So we can use that relation here, that is mvr is equal to nh upon 2 pi. Now here, what is this mvr? mvr is the angular momentum. Now what is its value? It is 4.2178 multiplied by 10 to the power minus 34. That is equal to n into, what is the value of h, students? H is what? H is Planck's constant, and that is equal to 6.626 into 10 to the power minus 34 joules second, and that has to be divided by 2 pi. Okay, so this would be 2 into, what is the value of pi? It is 3.14. Okay, so it is 3.14. Now what would n be equal to? That is the position. 4.2178 multiplied by 10 to the power minus 34 multiplied by 2 multiplied by 3.14, and that is divided by how much? 6.626 into 10 to the power minus 34. Now this comes out to be 4. You just calculate it, it will come out to be 4. That is, now we got to know where the electron is present. So where it is present in the 4th energy level. Correct? Now what is our question? N is equal to 4. We have to find out the wavelength of wave emitted when this electron moves to lower energy level, next lower, right? It means it is going from 4 to 3, that is, this comes out your N2. Now can you find out the wavelength? It is 1 by lambda is equal to RH, that is the Rydberg's constant, 109678, multiplied by 1 upon 3 square minus 1 upon 4 square. Now this comes out to be 1 by lambda is equal to 109678, and this would be what? 1 by 9 minus 1 by 16. So 1 by lambda will be equal to 10. Sorry students, it's going somewhat opposite. So 1 by lambda will be equal to 109678 multiplied by 16 minus 9 upon 16 into 9, right? And from here your lambda comes out to be 1.87 into 10 to the power minus 4 centimeter. So what is the wavelength of the wave emitted? It is 1.87 into 10 to the power minus 4 centimeter. So this would be our answer, right? So that is the wavelength of the wave emitted is equal to 1.87 into 10 to the power minus 4 centimeter.